Hi grade 11s. Today we are going to be looking at empirical formulas. So this is going to be lesson 2.9. So lesson 2.9, so empirical formula. So we're going to start off by looking at percent composition. So right away, percent composition, think of something being composed, right? So what's something made of? What's it composed of? So percent composition is what something is made of and by what percentage it is. So the question here is find the percent composition by mass of calcium nitrate. So in order to do this, you need to know the you need to know the chemical formula of calcium nitrate. So you know that calcium has a charge of 2 positive, nitrate is 1 minus, so you're going to need 2 of the nitrate ions for every 1 calcium. So this is going to be your formula here. So calcium, NO3, 2. Your first step, the question is asking you to find the percent composition by mass. So I'm looking at grams for this. So you're going to go ahead and you're going to find the molar mass. You're going to add those all up together. So 1 calcium, 2 nitrogens. So 1 calcium plus 2 nitrogen plus 6 oxygens. And if you do that, you end up, I'm just going to get my book out. You end up with a mass of 164.1. So this is going to be 164.1, and the unit is grams per mole, okay? So that is your molar mass of calcium nitrate here. Now, we're going to find the percentage. So we know that calcium has a mass of 40.1. That came from our periodic table. So if we take the mass of calcium and we divide it by the overall mass of the calcium nitrate and we multiply that by 100, we end up getting our percent of calcium. So calcium nitrate by mass is 24.44% calcium. So next we're going to look at nitrogen. Now the important thing for this one is to note that you have 2 nitrogens, okay? So the percent of nitrogen is going to be 2 times the mass of nitrogen, which is 14. Again, that came from the periodic table. And you're going to divide that again by the overall mass of the whole molecule and then multiply by 100. So we're at 17.06% nitrogen. And then lastly, oxygen. You've got 6 oxygen atoms, so 6 times 16. That's the mass of the oxygen in the molecule, divided by 164.1 grams times 100, 58.50%. Okay, so these are our percent composition, excuse me, and it's all based on masses from the periodic table. Now, types of formulae. So formulae is just the Latin plural of formula. So we're going to go through 2 different kinds. So the first one is the empirical formula, so EF. And this is the simplest formula, and it's going to give the ratio only of atoms in the molecule. So it's not giving us the actual number of atoms. It's just telling me what ratio they're in, okay? So an example of this is ethane. So ethane has a chemical formula of CH3. So what is the ratio between carbon and hydrogen for this particular compound? And it's going to be 1 to 3. So carbon to hydrogen will have a 1 to 3 ratio. So that will be the empirical formula. So empirical formula CH3, it's like the reduced version. So in terms of math words, if you were to put it in lowest terms, you'd reduce it. So CH3 is the empirical formula. Now we have something called the molecular formula. So this also gives the ratio, but it also gives the actual number of atoms in a molecule. So for example, ethane is C2H6. So we talked about how the empirical formula of ethane is CH3. The molecular formula of ethane is C2H6. So it's telling us that we've got actually 2 carbon atoms for every 6 hydrogen atoms. And so what is the ratio of carbon to hydrogen? It's 2 to 6, but you wouldn't leave it like that. You want to reduce it, right? So you're going to reduce to 1 to 3. So you'll notice that the empirical formula and molecular formula, they've each got the same ratio. They've got the same ratio, but different actual numbers of molecules. So in this particular case, the molecular formula is 2 times the empirical formula. So that's not always true, that number can change, but this is the number that we're after when we're doing these problems. So how are the molecular formula and the empirical formula related? Okay, so we're going to figure that out here. So the empirical formula of a compound is CH2. So we've got a 1:2 ratio here. Its molar mass is 56 grams per mole. So molar mass, that is going to be from the molecular formula. The molar mass is 56 grams per mole. So what would be the molecular formula? So I'm going to get you should pause the video now and see if you can figure this out and spend some time figuring it out. Okay, so hopefully you've done that. Some people approach this as a trial and error thing, so they just keep fiddling around with the numbers till they get the right number. But there is a more logical way to approach it. So what you can do is you can say, well, let's look at CH2. If I look at CH2 and I add those up, I've got 1 carbon, 2 hydrogens, so I end up with a mass of 14 grams per mole. The molecular formula is 56. So if I divide the molecular formula by the empirical formula mass, so 56 divided by 14, if I do that, so 56 divided by 14, you get an answer of 4. So what that tells you is that the molecular formula is 4 times the empirical formula. So if the empirical formula is CH2, if I multiply CH2 by 4, I end up with C4H8. Okay, so this would be my molecular formula. So we're going to use this information here, this molecular formula mass divided by the empirical formula mass. We're going to use that because that's a ratio, and we're going to use that in our next questions here. Okay, so we're going to go through how to find the empirical formula. So the empirical formula, we're going to use percent composition by mass data. And then we're going to use that to find the mole ratios between all the different elements in a particular compound. So your strategy here, you're going to find the moles of each element and the ratio between them. So we're going to learn this by doing an example here. So a compound is 31.25% calcium, 18.75% carbon, and 50.00% oxygen. So we're going to find the empirical formula. Now, when you're doing these, you should always assume 100 grams at the top here, because you need to have that in order to use our percentages. So for example, 31.25% calcium, if I have 100 grams, that 31.25% is going to transfer into just being 31.25 grams, which makes life easy for me here. Okay, so you're going to set up a little chart for yourself. This is often the easiest way to do it. Well, I think it is. So element, grams, moles, and then ratio. So these are our headings here. So if I have assumed 100 grams calcium, so I've got 31.25, carbon, I'm going to have 18.75 grams, and oxygen will be 50.00 grams. Now, in order to find the moles, to convert from grams into moles, I'm going to divide by the molar mass, and you can do your DA here if you want, but you can just know that you need to divide by the molar mass. So 31.25 divided by 40.01, and if I do work that out, I'm just going to take a shortcut here, I'm going to get 0.7793. Next one, I'm going to take 18.75 divided by 16, and for this one, I am going to, no, 12, geez Louise. 12 for carbon, sorry about that, is going to be 1.562. And then lastly, 50.00 divided by 16 is going to be 3.125. Now, so these are my moles. Now, just like the copper sulfate lab, if you want to compare or find the ratio between them, you want to find out how many times they go into each other. So you're going to have to divide by the smallest number. And if you divide them all by the smallest number, which is 0.7793, you're going to get a ratio of 1 here. This one, 1.562 divided by 0.7793 is going to end up being 2. And then if we take 3.125 divided by 0.7793, you're going to end up with 4 here. Now these are the moles. So this tells us what the ratio is. So it's 1 to 2 to 4. And so then if we want to write that molecule, we're going to have 1 calcium, 2 carbons, and 4 oxygens. And so this is going to be the empirical formula here with a ratio of 1 to 2 to 4. Okay? I guess I had more room. Now, another example, a compound is 43.67% phosphorus and 56.33% oxygen. Its molar mass is 284.0 grams per mole. Find the empirical formula, molecular formula. So we're going to just start with the empirical formula, and then we're going to use that data to find the molecular formula. So again, we are going to assume 100 grams. So we're going to have our elements. I'm going to write my chart here. So elements, grams, mole, and ratio. So the element, I've got phosphorus and I've got oxygen. So phosphorus is going to be 43.67 grams. Oxygen is 56.33. Divide by the molar masses to get into grams. So phosphorus is 31. And for that we end up with 1.409. And then this one, 56.33 divided by 16. For this one, we're going to get 3.521. Now, to determine the ratio between them, we want to divide by the smallest number, so that's going to end up being 1. And now if I take 3.521 divided by 1.409, I end up with 2.5. So this is a problem here, okay? We can't have 2.5 in our formula. So when something like this happens, what you need to do is you need to multiply it to get to the to whole numbers, right? So if I multiply this by 2, I get to 5. But what I do to one thing, I have to do to the other. So now I've got a ratio of 2 to 5. So this compound, the empirical formula is P2O5. Okay, so this would be my empirical formula. Now, you're not done for this question because now it asks you to find the molecular formula. Now remember, you've been given the mass. I'm just going to highlight it here. So this is the mass, right, of the molecular formula. So we're going to use that to find the molecular formula because we've got the empirical formula, so we can tell how those are related by looking at the mass. So I'm just going to do this on my next slide. So I've got P2O5 again. So looking at that P2O5, if I add those up together, that's 2 phosphorus and 5 oxygens. I end up with having 142 grams per mole. That's going to be the molecular mass of P2O5. It told me in my question that I've got 284 for the molecular formula. So I know that the molecular formula mass divided by the empirical formula mass is going to be 284 divided by 142. That's going to give me 2. What that means is that this means therefore the molecular formula is 2 times the empirical formula. Okay, now if you do not get a whole number for this, you have done something wrong. Okay, it has to be a whole number there. Otherwise, go back. You've made a mistake somewhere. So instead of it being P2O5, so P2O5 times 2 is going to be P4 O10. And this is the molecular formula then of this particular compound. Now, your assignment here is exercise 12. The answers are already written on the sheet. They're in brackets behind each question, I believe. So make sure you give this a try. This can be a tricky concept for people, so make sure you're trying it out. Okay, thanks everyone.